So today I am going to talk on the ECG leads. So during each heartbeat, whatever the electrical potentials are generated in the heart, they are conducted to the body fluids. And as you know, the body fluid is a good conductor of electricity. So the electrical potentials generated in the heart during each heartbeat is conducted to the body fluids, and these electrical potentials are picked up by the electrodes that are placed over the specific points over the body surface. So the recording of this electrical activity of the heart is called as electrocardiogram. Okay. So in this class we are going to see only on the leads of the ECG. So in next subsequent videos we will see about the waves interval segments of the ECG. So let us move down to the ECG leads. Now if we see the ECG leads, there are main two types of the ECG leads. One is bipolar leads, another one is unipolar leads. In case of bipolar leads, there are two recording electrodes are used. So here the two electrodes are there, which are also called as active electrode. One is connected to the negative terminal of the ECG machine, and another electrode is connected to the positive terminal of ECG machine. So both are recording electrodes, and they are kept over the body surface on both sides of the heart. So they will record the potential difference between the two points, whether they are kept on right arm or left arm or any other parts of the limb. So they will record the potential difference between the two points or surfaces. In case of unipolar lead, only one active or recording electrode is used, that is connected to the positive terminal of the ECG machine, while the another electrode is called as indifferent electrode, that is connected to the negative terminal of the ECG machine. So this indifferent electrode will coming up from the all the other three limbs like right arm or left foot, and these three electrodes coming from the limbs will pass through the electrical resistance, then it is connected to the negative terminal of the ECG machine. So this indifferent electrode as is coming from the three limbs, so it is kept at a zero potential. So this is the reference potential. Okay, so this is how you can see the bipolar leads and the unipolar leads, and the how the electrodes are kept over the body surface and how many recording electrodes are there. Okay, so in the bipolar two recording electrodes, and in unipolar only one recording, and other one is a indifferent electrode that is kept at a zero potential. Okay, so in the ECG leads there are total 12 leads are there, so it is called as 12 lead ECG. So let us see how they are now. So first group of lead is bipolar lead. Okay, second group of leads is unipolar leads. So in the bipolar leads there are total 3 leads are there. They are also called as standard or classical limb leads, as it is described by Einthoven. So it is also called as Einthoven's leads. So these are the only 3 leads which are called as bipolar limb leads. Other 9 are there in the total 12 lead ECGs. They are all unipolar leads where only one active electrode is used. So in this first group in the unipolar leads there are augmented limb leads. Okay, so there are 3 augmented limb leads are there, and the last 6 leads where the electrodes are kept over the chest surface covering the heart, so they are called as precordial or chest leads. So there are total 6 chest leads are there. So here the 3 bipolar limb leads, 3 unipolar limb leads, and the 6 unipolar chest leads. So total becomes 12 leads. So this is how the 12 leads are there. One group of is bipolar limb leads, lead 1, lead 2, lead 3. They are also called as standard or classical limb leads. There are no any bipolar chest or precordial leads. In case of unipolar, there are unipolar limblets AVR, AVL, AVF. A stands for augmented, V stands for unipolar or voltage. The R, L and F, these are the suffixes used for right arm and left foot respectively. So these are the three augmented limblets, and there are six chest leads are there, or precordial leads starting from V1, V2, V3, V4, V5 and V6. So total becomes these 12 leads. Now we are going to see about the placement of the leads in all this 12 leads system. So first we'll start about the bipolar limblets, that is standard limblets, where the electrodes are placed and how the ECG is recorded on all these three leads. So in the bipolar leads, there is first one is the lead 1. Okay, this is the lead 1, where the two electrodes are kept over the right arm and another electrode is kept over the left arm. Both are active or recording electrode. So this right arm electrode is connected to the negative terminal and the left arm electrode is connected to the positive terminal of the ECG machine. Okay, and if you pass an imaginary line connecting this right arm point to the left arm point, you will be getting one direction or arrow that is called as axis of the lead, that is pointing towards the 0 degree, because axis of the lead is oriented in different directions and it is expressed in degrees. So the axis of this lead 1 is 0 degree. Okay, now the lead 2. So in the lead 2, the two electrodes are again used active electrodes. One is kept over the right arm again, another one is kept over the left foot. So right arm electrode is connected to the negative terminal and the left foot electrode is connected to the positive terminal of the ECG machine. Okay, and if you join these two points over this right arm and left foot, you will be getting the axis. This is the axis of this lead, that is pointing towards down at 60 degree angle. So this is the axis of the lead. Now in the last one in this bipolar limblets, it is a lead 3, where the two active electrodes are kept over the left arm and another is kept over the left foot. So the active electrode coming from the left arm is connected to the negative terminal and the electrode coming from the left foot is connected to the positive terminal of the ECG machine. And if you join these 2 points, left arm and left foot, you will be getting this axis that is going down at a 120 degree. Okay, so this is how the placement of the electrodes in the standard limblets and their axis. Let us move down to the second group, that is again the limblets, but these are the unipolar. They are called as augmented limblets. So here in augmented, the limbs electrodes are kept over the limbs in such a way that the potentials are magnified. Amplitude of that potential is increased by 50%. So it is called as augmented. So these are how the three augmented limbs are there. Let us see their placements and the axis of all these three leads. If you see the first one, that is the AVR, A for augmented, V for voltage or unipolar, R is for right arm. So here, as name suggests, R means here the active electrode, again it is unipolar, means one active electrode, other is kept at a 0 potential to the indifferent electrode. So here the one active electrode, another is indifferent electrode, that is inactive, kept at a 0 potential. So in case of AVR, the active electrode is kept over the right arm, okay, and that is connected to the positive terminal of the machine, and the other two limbs, that is the left arm and left foot, they are passing through the electrical resistance of 5000 ohm and they will be connected to the negative terminal of the ECG machine. So here is the active electrode that is connected to the positive, and this indifferent electrode that is coming from the other two limbs, that will pass through the resistance first and it is connected to the negative. So as unipolar, they will record the electrical potential from the specific point of the heart area. Because it is unipolar, it will not record any potential difference between the 2 points. Okay. So in case of EVL, as L stands for left arm, so here the one electrode is kept, active electrode, over the left arm, and that is connected to the positive terminal, and the other one that is kept at a zero potential, that is coming from this other two limbs like this, and it will pass through a resistance and it is connected to the negative terminal. This is the indifferent electrode. Okay. Then the lead EVF, F stands for left foot. So here the one active electrode is kept, and this is connected to the positive terminal of the machine, and the other indifferent electrode is coming from the other two limbs, right and left arm, and they are passing through the resistance and it is connected to the negative terminal of ECG machine. If you see the axis of these three augmented leads, the AVR is going up about 1 minus 150 degree, that is like this one. Okay. Then for the AVL, it is going up at minus 30 degree, and if you see the axis of EVF, it is going down vertically, and this angle of this axis is plus 90 degree. So these are the how the placement of electrodes and axis of augmented limb leads. Now we'll see the last one, where the electrodes are kept over the chest surface covering the heart. So they are called as precordial or chest leads. So here the 6 leads are there. So 6 electrodes are kept, active electrodes, and other is indifferent electrode as it is unipolar lead. So these are the 6 points where the 6 active or recording electrodes are kept, and they are named from V1 to V2, V3, V4, V5 and V6. On these 6 points, the recording electrodes are kept. Another electrode is connected to the negative terminal of the machine, that is called as indifferent electrode. Let us see the placement of the all the 6 leads, chest leads. The V1 is kept at a 4th intercostal space. This is the 4th intercostal space, right side, just lateral to the sternum. So how to count the intercostal space? Take this point, manubriosternal joint, that is the sternal angle where the second rib is attached, and below the second rib the second intercostal space is there, then one rib below that is third, and likewise we will be getting fourth. And this is how we can see the various intercostal space we can see, or we can palpate the various intercostal space by this landmark, that is sternal angle. Okay. So this is the V1 that is kept at the right 4th intercostal space lateral to the sternum. Then this V2, this is kept over the 4th intercostal space, but it is on the left side lateral to the sternum. This V3, it is kept in between the V2 and V4. So we have to see the V4 where it is. The V4 is kept in the left 5th intercostal space, just inside the mid clavicular line. Okay. So this is the point of apex bit. So here is the V4 is there, and in between the V2 and V4 we will be getting this V3. Okay. Then is the V5 electrode, where the active electrode is kept over the again the left 5th intercostal space, but it is in the anterior axillary line. And last one is the V6, again in the left 5th intercostal space in the mid axillary line. So this is how the electrodes are kept over the chest, and they will be going anterior to posterior side of the heart. So these electrodes are called as transverse leads. Okay, so these leads are called as transverse leads. So the chest leads, they will pass from anterior to posterior side of the chest. So they will represent the transverse or horizontal plane of the heart, while the limb leads, they will go from up to down, that is from up to the superior to the inferior side of the heart, and from left to right side of the heart. So they represent the vertical or frontal plane of the heart. So the limb leads will be the frontal plane leads, and the chest leads will be the transverse or horizontal leads. So this is how they represent the heart in various angles or directions. So this is how the placement of electrodes in the chest leads, precordial leads. So at these 6 points, one active electrode is kept. Okay, so this is the active electrode that will be kept on V1 to V6 point, and this will be going down to the positive terminal of the ECG machine, while another one is indifferent electrode which is coming from the all these three limbs. Okay, then it will pass through the electrical resistance and it is going down to the and connected to the negative terminal of the ECG machine. There is another one electrode is kept here that is fixed to the right foot, and this is acting as a earthing. That is it prevents the electrical interference while recording the ECG. So this is acting as a earthing. Okay. Now here, once we are done about this, all these 12 leads, their placement and how the recording is done, one should aware about the basics law of the electrocardiography, why we get either positive waves or negative waves or biphasic waves in the ECG, electrocardiogram. Okay, so here the first rule is that whenever the wave of depolarization or repolarization, it is moving towards the positive, that is the recording electrode, we get the positive complex in the electrocardiogram. So what is this rule? So whatever the wave of depolarization is there, that is the current flow in the heart during each heartbeat, it is moving towards the positive terminal of the lead, that is the recording electrode. This is the, suppose this is the axis of the lead and this is the positive end of this lead. So whenever the current flows towards the positive electrode, that is the recording electrode, we get the positive deflection in the electrocardiogram. Suppose here the wave of depolarization or repolarization is moving in reverse direction compared to the positive electrode, this one. Now here the wave of depolarization is going away from the recording electrode. We get the negative deflection in the ECG. Okay, I understood this. If the current flow in the heart is going up and down vertically, either moving up and down as compared to the positive electrode, then we get the biphasic complex in the ECG. So this is how the basic laws are there by which we can easily come down why we are getting positive waves or negative waves or biphasic waves in the ECG, that is electrocardiogram. Let us again revise the axis of the leads so we can get the idea about this, why we get positive or negative waves in the electrocardiogram. So this is the lead 1 axis, 0 degree. This is the lead 2, that is the plus 60 degree. This is the lead 3 axis, 120 degree. This is the AVR axis, that is going up, minus 150 degree. This is the AVL going up to the left side, minus 30 degree, and this is going down vertically, that is axis of AVF. Now if we compare the mean electrical axis of the heart, that is the net current flow during the depolarization and repolarization of the heart, if you see this arrow means it is the vector, that is the current flow during the most part of the depolarization or repolarization. It is normally going down from the base to the apex, and here the angle is normally 60 degree. So this is the mean electrical axis of heart or mean vector of the heart. So mean vector or mean electrical axis means this is the net current flow that occurs during the most part of the depolarization and repolarization of the heart, and this is at an angle of 60 degree, though it ranges from minus 30 to plus 110 degree. Okay, if this current flow is going to the positive terminal of the recording electrode, we get the positive waves. If the current flow is going away from the recording electrode, we will be getting the negative waves in the ECG. And these are the axes of all the chest leads. This is the V1, V2, and this is the mean electrical axis of the heart. So we can easily come out this V1 and V2, they are little bit moving away from the mean electric axis of the heart, while the V3, V4 and up to the V6, they are in line with the mean electrical axis. So we will be getting the positive waves here starting from the V3 to V6. In V1 and V2, here the axis of these two leads and the current flow, that is the current flow is going away from the, these are all the positive electrodes what we are getting here. So it is going away from the recording electrode. So we are getting here predominantly negative waves in V1, V2, and from V3 to V6 we will be getting mostly the positive waves, especially V4, V5 and V6, because they are in line with the main QRS, that is mean electrical axis of the heart. Okay. Now if you see the all the leads, they will view the heart in different direction. Okay, each will view the heart by a different direction or by different angle. So some leads get a good view of anterior portion of the leads. Some leads will view the heart, or it will record the electrical activity of inferior portion of the heart, and some leads will record the electrical activity of lateral portion of the heart. So this is how the recording electrode of each lead view the each portion of the heart. So some lead will represent the anterior portion of the heart, some leads will represent the inferior portion, and some leads will represent the lateral portion of the heart. So whatever the abnormality occurs in each leads, we can easily come down that which part of the heart is mostly affected. Suppose some abnormal changes are seen on only anterior leads, then we can come down to, we can note that there is some problem in anterior portion of the heart. So likewise we can also come to know about the lateral and inferior leads also. Let us see which are the leads which will represent this all the three portions of the heart. So V3 and V4, they represents the anterior wall of the heart. So whatever if there is abnormality occurs in these two leads, it shows that the anterior portion of the heart where is the problem is there, while the V1 and V2, they represent the septal portion of the heart. Lead 1, EVL, V3, V5 and V6, these 1, 2, 3, 4, these leads will represent the lateral wall of the heart, because they view the lateral portion of the heart. So whatever the abnormalities occur, so we can come to know that there are some abnormalities in the lateral of the heart. And some leads will view the heart, that is the inferior portion of the heart. These are the lead 2, lead 3 and EVL. So these are the inferior leads. They are called as inferior wall leads. So by noting the abnormalities, we can easily come to know which portion of the heart is mostly affected. So this is the ECG machine which records the electrical activity of the heart in each lead. So this is the plastic coated heat sensitive paper is the ECG paper, which will record the electrical activity with the help of stylus, which gets hot whenever the electrical potential will pass through it. It will move up and down, and that will draw a black line on the ECG paper in the form of various waves, segments and intervals. So it can be recorded manually or automatically also. So nowadays the computerized ECG machines are available, which will record the electrical activities of the heart in all the leads automatically when the electrodes are all placed on the particular points over the body surface. So this is how the ECG paper looks. It is made up of millimeter square graph paper. If we enlarge this graph paper, one part of this, we will be getting like this. This is how the millimeter square graph paper looks. There are two types of the calibrations are there on the graph paper. One is horizontal, that represents the time or duration, and another one is the vertical calibration that will records the voltage or amplitude of each wave. So this vertical line represents the voltage or amplitude. So one small box, if you see again, it is the squares, millimeter square is there. So 1 millimeter on horizontal side represents duration, means 0.04 second. If we see the 5 small box that is in the one large box, we will be getting 0.20 second. Okay, this is how the horizontal calibration is there. Okay, the vertical one small box is equal to 0.5 millivolt, that is the voltage or amplitude of the each wave. And if you see the one large box that is made up of 5 small boxes is equal to 0.5 millivolt. So this is how we can easily come down what are the durations of each waves or duration of interval or segments, and what is the amplitude of the each waves. So this is how we have done about the ECG leads. In the next videos we will see about the how the waves intervals and segments are formed because of the this electrical potential generated during each heartbeat. Okay, thank you.